G'day. Today I'm going to talk to you about break-even analysis and forecasting profits. This is another flip lesson for Business Studies 3 students. Sales forecasting. What we attempt to do is to use a cost volume graph, where on there we can show what stages we make a profit, what stage we break even, and at what stage we make a loss. It shows a relationship between the total revenue that is generated by a business and the total cost, all on the graph. So as I said, profits can be shown graphically. When we look at the costs, we've got to distinguish between fixed cost and total variable costs. Fixed costs are the costs that do not vary regardless of how many units are sold. For example, I have to rent my premises. It doesn't matter if I sell 1 unit or 1,000 units. I have to pay my staff, I have to pay insurance, and so on. Now there are costs that do vary. Okay, so if I have a clothing store, so for every article that I sell, I have a cost of goods sold. So that is my variable cost. Let's look at the break-even analysis itself. It determines the level of sales needed to cover all costs, fixed and variable costs. I'll explain that in a bit more in a moment. It shows sales above the break-even point means a profit, and conversely, if you're below that break-even point, it means you're making a loss. There's a formula for this, expressed in terms of break-even amount of units that you need to sell, which is equal to the total fixed costs over the sales price minus the variable cost per unit, sometimes also called the contribution margin. You can use your text on page 416, and I'm using that example to work through the calculations there. So in that instance, there were fixed costs of $600,000. The sale price per tennis racket is $200. The variable cost of each tennis racket that is purchased, the cost of goods sold, is $80. So if we use our formula that I've shown you before, total fixed cost over sales price minus variable cost, let's just start working that out. So the 600,000 goes in the fixed cost there. The difference is in the sale price, which is 200 minus the variable cost 80 is shown there. So it means we have to then divide 120 into 600,000, which leaves us with 5,000 units. So that means that in order to break even, this business needs to sell 5,000 units. I presume it's on a yearly basis. If you want to put that into context in relation to a weekly basis, then divide that 5,000 units by 52, and it means that per week this shop has to sell 100 tennis rackets per week. So simply, if you sell 80 units per week, you know you've made a loss. If you sell 150, obviously you're in good territory, making lots of profit. So what does it mean for better rackets, this example on page 416? So 5,000 units need to be sold, and as I've already said, it means just under 100 rackets need to be sold every week to break even. So if they sell more than 100 rackets, if they sell less, I beg your pardon, they've made a loss. If they sell more than 100 rackets, they've made a profit. Let's look at the graphical example using a cost volume graph. Here's the example from page 416. There's two important lines. First of all, the sales, the total revenue curve. You can see that once we start selling units, it goes from 0 all the way up here on the blue line. The total cost, remember, is the fixed cost. It consists of the fixed cost, which at 0 units sold is still going to be 30,000. And as we then start selling units, we add the variable cost per unit to it. You can see after a while they cross up here, and that represents the break-even sales point. Okay, so let's look at another way. If we are selling 100 units, then we're going to be making a loss. That's represented graphically there, of 100 times 10 there. And if we say, okay, we are at this point up here, you can see that you can graph the amount of profit that's being made. Let's go one step further. Remember, the fixed costs, they stay the same all the time, and that's why the total cost curve started from there going upwards like that. And to that, you've got the variable cost, which obviously going to be added on and that increases as you sell more units. When you combine the two, you put the variable cost on top of your fixed cost, then that equals to the total cost. So the fixed costs are down here, the variable costs start adding on, which means then this line here are the total costs, and that's what we saw on that first graph that I showed you. I'm going to use this figure 1217 and work through it bit by bit. So let's examine what we saw. Sales price of 1,000, variable cost of about 800, and fixed cost of 30,000. Just coming back to our graph again. Okay, that's 30,000. Remember that this is in thousands. So that's where the total cost curve starts at the fixed costs. Okay, and our sales are increasing up here. The sales price is 1,000, and the variable cost that's factored in this line is $800 per unit. So let's continue. So using our formula, total fixed cost over sales price minus variable costs. So we've got 30,000 over 1,000 minus 800, which is 30,000 over 200. So therefore the number of units that we need to break even with this business is 150 units. If these costs are yearly costs, then it means that you can divide this figure by 52, and for ease of exercise, let's say it's 50 weeks. It means that you need to sell 3 units per week. You can also see this information in a tabular form, which I've got here. Okay, so the fixed costs are always $30,000, and these are the number of units, okay, in thousands. So as we go up, we've got variable costs, and that plus that equals the total costs. And at 25,000 units, or 25 units, I beg your pardon, times $1,000 per unit, you have the revenue of that much. So when we take the revenue and minus the total costs, we get a profit. You can see a minus here of 25,000, and so on up we go. Let's have a look at 100 units. 100 units, the fixed costs are still the same. The variable cost at 800 equals 80,000. So the total cost is that plus that gives you that. The revenue, 100 units at 1,000 gives you that much revenue. So we take the total cost from that, we still have a loss of minus $10,000. When we finally get up to this point here, and we already worked this out, that 150 units is required to break even. So that means that the total costs are equal to the revenue, the total revenue. Right? And once you start getting above 150 into this territory, you can see how the profit is increasing. And that's really important information for any business to have as a yardstick, and they can use that as a forecasting tool. Let's just summarize that information again in the graph. Okay, so at 30,000 is our fixed costs, and the total cost curve is the red line that goes up here. The sales start up here and they intersect at this point here, which is 150, what we worked out. So that's a break-even point. So this area here is your profit-making area, and down here you've got the loss-making area. I'm hoping that has been useful to you. It's an essential part of any forecasting for a business, whether you are in your business or starting off. What I'd like you to do is to go to page 423, and there's some revision questions 1, 2, 3 and 5, and I'd like you to do an exercise of your own, which is question 7 on the same page. I hope you found that useful. Thanks for listening, and there'll be plenty more other exercises following from this.